All right, so we're going to talk about trigonometric graphs. So sine and cosine functions repeat their values in a regular fashion. Remember that the circumference of the unit circle is 2 pi. So we're back to the unit circle again. If you're in my class, we did the unit circle, then we kind of went off and did, we still kind of used our unit circle, and then we were doing law of sine and cosines. And now we're back into that unit circle. And so we're remembering some of the parts about our unit circle. So the circumference of the unit circle is 2 pi. The terminal points determined by the real number t is the same as t plus 2 pi, because if we remember we talked about coterminal angles. So if I'm at t, and let's just say my t is here, if I go all the way around and add 2 pi, I'm still that same terminal point. So that's where we're talking about those co-terminating type of situations. So the values of sine and cosine are unchanged by adding a multiple of 2 pi. Thus they are referred to as periodic. So the periodic properties of sine and cosine, the functions of sine and cosine have a period of 2 pi. The sine of t plus 2n pi is going to be equal to the sine of t, because the value will be the same, that 2n pi that's going around the unit circle again. So no matter how many times, and that's what that n means, is no matter how many times you go around the unit circle, it's still going to be equal to the same value as the sine of t. Same thing will happen to cosine of t. As we go around and we go around and we go around, we are still landing at that same point, as long as it's a multiple of 2 pi. And of course, that's for any integer n. The sine and cosine functions repeat their values in any interval of length of 2 pi. So to sketch their graphs, we're going to first graph one period to sketch the graphs on the interval of 0 to 2 pi. We could try to make a table of values and use the points to draw the graph. Since no table can be complete, we're going to look more closely at the definitions of the functions. So recall that the sine t is the y-coordinate of a terminal point. So that point on the unit circle determined by should be determined by the real number t. So how does the y-coordinate of the point vary as your t increases? So with our y values, it's easy to see that the y-coordinate increases to 1 and then decreases to -1. And it's repeatedly as the point travels around the unit circle. So let's go look at that for a second. So you can see the increase from 0 to 2 pi because the sine value will increase from 0 to 1, and then back down on the next part, it goes back down from 1 to 0. So let's go look at our unit circle here. So if we start here, our y value is equal to 0. It goes all the way up to pi over 2. It becomes a 1. It goes back down, becomes 0 at pi. It comes down, it becomes -1, and then it's back to 0. So that's where they're talking about it will increase and decrease and increase and then it continues to decrease here. And then it actually kind of increases back. So we've got kind of a little chart here showing what's happening to the value of our sine and our cosines. And this is a graph that we are looking at of the unit circle. This is the y equals sine t. So what they did right here is they took the unit circle and they took it apart and they put it on the graph. So basically, they took, so this is at 0, and then this would be up at this point here is that point right there. So this is graphed up here. The top half of our circle is graphed here, and the bottom half then goes there. And that's what it looks like for our sine graph from 0 to 2 pi. So this would be at the point of pi. So they've kind of broken it apart. This bottom part's down here, and the top part is kind of pulled open and put up there. so that it goes from 0 to pi in this fashion. And then we've seen this chart before of the values. Now, if we want a more accurate graph, we have to graph more values. So here we've got a graph, and there's a lot more values on it. To put a lot more points on it in my class, you're just going to need to do a sketch. You don't have to use a graphing calculator. We're going to graph all of these without one. This is one period of sine going from 0 to 2 pi. And this would be a period of 2 pi of our sine in a sine wave. This would be a graph that's been multiplied by 2. So it's our sine is right there, one period of it. And here we've multiplied by 2. So it's just like with college algebra, where it's transformations. It's multiplied by 2, so those values are going to go up. And then when it's multiplied by a fraction, it's going to shrink towards the x-axis. So it's stretching and shrinking, just like we've seen when we were in college algebra. Same thing happened here. They're multiplying by 3 and multiplying by 1/2. Now for the graphs of cosine, it is now symmetric with respect to the y-axis. So this is what a period of cosine looks like. So what I want you to notice is that sine looks like an S shape because it's a sine curve, so it looks like an S. And on our cosine, it looks like a C, like a cup. So that's kind of how you can tell the difference of which one is which. Now, when they are just a big line, the way you're going to be able to tell is it hasn't been transformed, is the sine will go through the origin and cosine will not. Unless, of course, it's been transformed where it's being moved to a different spot. So this is what a sine or a cosine curve wave looks like, where you've got a period of 2 pi happening there. When we are here, we're adding 2, so it's going to get moved up. This would be a negative cosine, kind of like a negative x squared kind of a thing, where the graph is now flipped over at this bottom part right here. And here they've done a negative and multiplied by 3. Now when we're looking at amplitude of a graph, the absolute value of the a is going to be the largest value the function attains. And so in our equation here, we have y is equal to a times sine of kx, and y is equal to a times cosine of kx. K is going to be greater than 0. It has an amplitude of a and a period of 2 pi over whatever that k is. 2 pi over k. So one complete period, as kx varies from 0 to 2 pi, would be 0 to, is greater or less than or equal to k times x, which is less than or equal to 2 pi. So if we divide everybody by k, 0 divided by k is still 0. We get our x by itself, and we get 2 pi over k. So that would be the interval to graph a period. And then, of course, we can shift our sine and cosine curves by, just like we had in college algebra, where it's like an x minus b for either sine or cosine. Of course, k is greater than 0 again. It will have an amplitude of a period of 2 pi over k, and the phase shift of b. So it's going to be just like it was in college algebra. If you see a minus b, it's going to go to the right. And if you see a plus b, it'll go to the left. And we can kind of see that here. This is minus pi over 3. So the graph shifted this way. A plus part here shifted our graph that way. Alrighty. So let's go actually do some graphing. Now that we have kind of a rough idea of what we're going to talk about, let's go actually do some sketching. But it's good to have a good beginning of information of what we're talking about. So the first thing we're going to sketch is, this will be example 1, we're going to sketch f of x is equal to 2 plus cosine of x. Now, f of x is always the same thing as y. So the first thing we're going to do is draw a graph. Get us started here. And we're going to do a 0 to 2 pi. We're going to do a complete part. So this would be pi. This will be 2 pi. We'll have a -1 and a +1. And we're going to add 2, so I know I've got to have a little bit more going on up here. So this will be 2, and this will be 3. I know it's going to go up positive because it's a +2. All right, so our initial graph, some of the things that we need to know, we're going to make a little hash mark here and here, because on our unit circle, let's talk about some of our values. We're looking at graphing cosines. We're looking at the x values. We're going to start at 1, and then we'll work our way to 0 for pi over 2. Then we'll be at -1 for pi, 0 for 3 pi over 2, and back to 1. So that means we're going to be here. This is our pi over 2. It's half of pi. I've split the pi in half. So we're going to land here. We're going to be here. At pi, we were at -1. And at 2 pi, we're back at 1. So we're just going to draw our graph. So it's going to kind of curve. Doesn't have to be perfect. But understand, it's kind of doing a little bit of curving out there. All right, now if we're doing 2 plus, that means every point moves up. So we will have our next graph is going to be 2 points up. This one will be 2 points up. 1, 2. And this one is 1, 2. This one goes up 2. And this one goes up 2. And that one might be a little high. Put it about right there. All right, so sketching again. So we're going to kind of curve down, come down, and go like that. Doesn't have to be perfect. It's just a sketch. And that's it. All right, let's go do another one. So if we have g of x is equal to the negative of cosine of x, which is the same thing as y, equals that, we have a reflection graph here. Alrighty, so let's go graph. So we'll be at pi, and 2 pi, 1, and -1. So recall that our graph, and let me make some extra hash marks in there so we can kind of flow. Our graph is going to hit at these points again, just like it did a minute ago. And I'm going to kind of just dash this one so we can see what the new graph is. Because it's a negative, it means it gets flipped. So think about a parabola goes this way and a negative parabola goes this way. So that means it's going to reflect and hit at these points. So it'll kind of curve around and then, whoops, curve that way. So this would be the dashed one is our y equals cosine of x. And this one would be the graph that we needed to graph. Again, not perfect. It's all good. All right, let's look at another one. If we have y is equal to 2 times sine of x, we are going to multiply each coordinate by 2. So let's start by graphing a sine curve. All right. So again, we're going to have pi and 2 pi. And then we'll do our halfways. So this is sine, so we've got to start with a different graph to begin with. And we're going to multiply by 2. So I'm going to need to go 1 and 2, and 1 and 2. So 1, 2, negative 1, negative 2. All right, so we're going to draw our original sine. Remember, sine goes from here, and then at pi over 2, it's at 1. At pi, it's at 0. At at 3 pi over 2, it'll be at negative 1, and then it'll be back at 0. So this is our original y equals sine x. So we can go off of that original graph, and those points we know from our unit circle. So that's how I know what it's going to do. All right, now if we're multiplying by 2, that means each value gets multiplied by 2. Well, 0 is still 0. But 1 times 2 would get me to 2. This will still be at 0. Negative 1 times 2 would get me down to negative 2. And then we're still at 0. So now we're coming up. And then we're going to come down. And then we're going to go back up. Try to make them curvy. This one's a little bit too pointy. But it's just a sketch. So on the same graph, let's do y is equal to 1/2 times the sine of x. So that means everything gets multiplied by 1/2. So on our sine curve again, the zeros are still going to be at 0. But 1 would now be 1/2. And negative 1 will be negative 1/2. So now it'll curve up like this. And then come through here. And catch that. And then curve up. So that gives us a couple of graphs that we've seen of sine with only having to draw one. All right. So let's go look at another example. So if we're looking at y is equal to negative 3 times the cosine of x. So recall that the amplitude is found by looking at the y is equal to a times the sine of kx. Or y is equal to a times the cosine of kx. So y is equal to a times the cosine of k times x. So that negative 3, that a is our amplitude, and negative 3 is going to be the absolute value. So the amplitude will be equal to the absolute value of negative 3. So the amplitude is 3, which tells us what our highest point will be. So let's go sketch a cosine. So we're going to have pi and 2 pi. We've got to have an amplitude of 3. We know this is being multiplied by that. So we've got to hit 3 over here. So 1, 2, and 3. And negative 1, negative 2, and negative 3. All right, so again, let's sketch the original graph. So I'm going to, again, do my pi over 2 and my 3 pi over 2. So at 1, we'll be up here, and then we're going to cross. And then down here, we'll hit our 1, and then scooch back up. Or sorry, our negative 1, and then scooch back up. So that's the original cosine curve. Now we've got an amplitude of negative, or being multiplied by negative 3. So 1 times negative 3 gets us down here at negative 3. We're still going to hit at the 0 because we're at 0 times negative 3. And then that negative 1 times negative 3 hits us up here at 3. And then we'll hit at 0 and again at negative 3. So our graph is going to come way up and kind of curve. Try to put a little bit of a curve instead of a straight line. It's sometimes hard to do, but just do your best. Now, the reason the amplitude is 3 is because we do hit the positive value of 3. That's the highest point. That's what the amplitude means, the highest point on your graph. All right, let's go to another graph. So if we're looking at y is equal to 2, oops, I wrote a little too early. Let's do it over here. Y is equal to sine of 2x. So this is where we're looking at the period is different because now the 2 is not outside of the sine, it's actually inside here on the x. So this is where we're looking at our period. Remember, our period is equal to 2 pi over k. So in this case, our k is equal to 2. So it'll be 2 pi over 2, which is just going to be pi. So that means our period is going to be from 0 to pi instead of 2 pi. This is where one period will land, because we're just graphing a period at this point instead of like a whole curve, sine wave or cosine wave, either one. All right, so let's go draw our graph. So you see I'm starting off the same way. I'm going to have 2 marks there, but instead of this being pi and 2 pi, our whole period will land in pi, and this will be pi over 2. So instead of 2 pi and pi, we have pi because that's our period length, and then cutting it in half will give us pi over 2. And then I'm going to make the hash marks in between, and then we're still at our 1 and our negative 1. All right, so same thing happens that we typically have on this graph. It's going to land here. It's going to go up to here, back down, down, and up. So curving up, curving around, and there we go. So we just shrunk it down into a pi, but otherwise it's graphing the same way. All right, let's go look at another graph. If we have y is equal to sine of 1/2 x. So again, the 1/2 was like the 2 on the previous one. So our period will be again 2 pi over k. Our k is 1/2, so 2 pi over 1/2. Remember, we don't divide by fractions, we multiply by reciprocals. So that'll be 2 pi, 1/2 becomes 2, so 2 pi times 2, which will get us 4 pi. So now our period is 4 pi. Alrighty, so let's draw our graph again. And we're still going to do 2 marks on our graph. We'll still have our 1. We'll still have our negative 1. But now it's at 4 pi over here. So half of 4 pi will get us 2 pi. So these are now 1 pi and 3 pi. But that part doesn't concern us so much as just having those 2 major ones, because you can easily see what the value is. All right, so then we're going to come up and down. I find it easier if I do the little dots, so I kind of have an idea of where I'm trying to go to. And it will look better if you have it more evenly spaced. If you're over just a little, it'll look a little more awkward. But still, not bad. I find that in any situation with the graphing, the fewer, even in college algebra, the fewer numbers you put on, sometimes the easier it is. If you just understand the shape and you put the end one and then the middle one, you can get enough feel and understand what those are, but the fewer numbers I put all over it, I think the easier it is. We're not trying to do exact replicas, we're just trying to understand what the graphs are doing, what a basic sketch is, and what we need to do with it, and how we can make it the best we can. All right, let's do y is equal to 4 times cosine of 3x. So here, we've got a couple of things going on. First of all, we need to know what the amplitude is. So the amplitude would be the absolute value of A, which is going to be the absolute value of 4, which would be 4. And then we need to find the period. So the period, again, is 2 pi over k. Our k is 3, so it'll be 2 pi over 3. All right, so now we know that part. Let's go draw a graph. All right, so we'll draw here. So we're going to put 2 marks again. So we know that our period ends at 2 pi over 3. So halfway between pi, or from 0 to 2 pi over 3, is going to be pi over 3. And then again, we're going to have our 1 and our negative 1, but we have to go up to 4. So we're going to stretch this up. There's 1, 2, 3, and 4. And we're going to have to stretch it down. Negative 1, negative 2, negative 3, and negative 4. Because we have a couple of things happening. So again, I'm going to start with sketching my basic graph. And this is a cosine. So I'm going to make my little hash marks again in the middle. So it's going to start here and come down. And then it'll go up like this. So that gives me a basic idea of what's going on. And now everything gets multiplied by 4. So 1 times 4, we're going to land up here. Still going to be at the zeros. Negative 1 will get us down to negative 4. And this one will get us back up to 4. All right, so we're going to try and kind of curve, come down and curve back up, and then curve out. So there we go. And that's that sketch. So it's not so bad. Like I said, try and don't figure out too much of what's going on. You can know and understand what those values will be, but if you get too involved with it, sometimes it gets to be a little mind-boggling of what are all the points. All right, so the next thing we're going to graph is y is equal to sine times x minus pi over 3. Now, with that one, that one's actually on the handout. Let's actually graph this other one. We could graph that one, but I'd rather do this one. If you're in my class, that one's on the handout. We talked about it a little bit ago. So let's actually graph this one. That way we involve all of our pieces and parts. So that y equals sine x minus pi over 3 is, that was the one that I showed you earlier where it shifted over pi over 3. So I'd rather do one where it involves a little bit more so that you have an idea. I'm trying not to make these like super, super long so you can have all of the ideas of what's going on without having to sit through too long. All right, so the amplitude of A, well, remember our A is going to be here. We are using, this is where for sine, this would be y is equal to A times the sine of k times x minus b. So this time we actually have a phase shift going on. So the A is going to be our amplitude, so the absolute value of 3 would be 3. And then we also want to know our period. And the period is always going to be that 2 pi over k for sine and cosine. Our k is 2, so 2 pi over 2 would just be pi. And then our horizontal shift, they call it a phase shift, but we know it's moving back and forth horizontally, just like it would in college algebra. So the horizontal shift is going to be what we see there. It's equal to the b. It's in the same format, so we know it's going to be pi over 4. And it's going to go to the right. If you understand which way it's right and left, and you write that, it'll make it easier when you go to graph. All right, so let's go draw our graph. So the first thing that we have to understand is we've got to have an amplitude of A of 3, so we're going to have to go up 3 hash marks, and we're going to need 3 going down. And we have to phase shift pi over 4. So I'm going to put a pi over 4 right there. And then I need, so instead of being at 0, we're at pi over 4. So then I'll need 2 others because I need the middle of the graph and I need the end of the graph. So if you recall, let's go back to one of our original graphs. So on a regular graph, and this is a sine, we would be looking at, trying to find original. There we go. Wrong page. So on a regular sine, we would be at 0 and then pi and then 2 pi. But our period is down to, we are at a period of pi. And so here is a sine graph where we had a pi for our period. So we were at 0 and pi over 2 and pi. So that's to kind of give you an idea of what we're looking at. We need this to be a full pi. So from pi over 4, so we're looking at pi over 4, and we need to add pi. So to get a common denominator of 4, so it'll be pi over 4 plus 4 pi over 4, we know that that last interval right here will be 5 pi over 4. So adding that pi, the interval starting from the phase, will give us an idea of what the number should be. Now between a 1 and a 5 will be a 3, because it's going to be halfway between there. So 3 pi over 4. Now again, I'm going to put my extra hash marks in there for my points of reference, but I'm okay with the limited values because you've got all the different denominators, and it can get a little more boggy, and we don't want to be bogged down. All right, so we know all of our values up here, and let's see what we can do at this point. So we are doing a sine curve. So we know that the sine will hit here. We know it'll hit here, and we know it's going to hit there. We know on this part it's going to be up at the 3, because normally it would be at 1, but it's got an amplitude of 3. And so this one's going to be down here at the -3. So that way we can kind of curve up and curve back down and curve back up. And again, try to make them curvy. It depends on how spaced out you make it to how well it will curve. Now, if you actually have to find the interval of the graph, you can find it just by adding the pi, because that's adding the b to them. So hopefully that's making sense on what to do. All right, let's go look at our next interval. And let's pause for just 1 second. If I wanted to find the interval, let me detail this out just a little bit more for you, just so you make sense with it. So if we're looking at the interval, on this interval, we know normally it's going to be 0 to 2 pi over k. And our k got us to pi, so we know that it becomes 0 to pi for this graph. But because we had a phase shift, we have to add the b to both parts. So that becomes our pi over 4 to our 5 pi over 4, because we added pi over 4 to both. So hopefully that gives you a little bit more idea of what you're doing to find those, if you need to also list the interval in which it happens. Okay? All right. Next graph. Whoops. Next graph, we are looking at y is equal to 3/4 times the cosine of 2x plus 2 pi over 3. Well, we need this x to be on its own. Remember that it's y is equal to a times cosine of k times x minus b. So we need this to be an x, not a 2x. Between these two, I can factor out a 2. So I can get y is equal to 3/4 times the cosine of 2 times x plus pi over 3. So I just factored a 2 out of each part of that. Now I want to write this in the way that it looks here. So y is equal to 3/4 times the cosine of 2 times x minus negative pi over 3, because that double negative would make it a positive in the part up there. Sometimes that will make it easier if you write it like it is in the formula to see what's really going on. So I need to know what my amplitude is. And my amplitude will be the absolute value of a, which is the absolute value of 3/4, which will be equal to 3/4. Our period is equal to 2 pi over k. Our k is equal to 2, so 2 pi over 2, which will be pi. And our horizontal shift is equal to b, and our b is negative pi over 3. Now, if you don't want to write it like this, just know it's going to be the opposite of that sign, because it's on the positive side. So negative pi over 3, and because it's negative, it's going to go to the left. And we need to know what our interval is. So for the interval, we know that it's 0 to pi, because that's our period. And so now we've got to do 0 minus pi over 3 to pi minus pi over 3. So 0 minus pi over 3, well, that's going to be negative pi over 3. And pi minus pi over 3, we can take our pi minus pi over 3, change this to a common denominator. So 3 minus pi, or minus 1, would get us 2 pi over 3. So you're just getting those common denominators to do that. So it'll be from negative pi over 3 to 2 pi over 3. So that's where our graph is going to land. Zoom out just a little bit so you can see all of those notes as we go draw our graph. Alrighty. So again, we're going to have some pieces over here because we've got our interval is over here. We're still going to be at 1 and negative 1 here. But we know that our amplitude is actually at 3/4. So this would be about halfway, so I'm going to make a little mark there, and I'm going to make a little mark there because we'll actually be at the 3/4 mark because of our amplitude. All right, and I know that I have to be at pi over 3, and I'm going to land over here at 2 pi over 3. So over here we're going to be at pi over 3, and at the back end we're going to also be at 2 pi over 3. So this one's a little bit harder to look at the graph and go, what are we doing here? Because you're not all on one side. You are on two sides of your graph, so you have to kind of look at it and figure out what works best for you as far as making the hash marks and where you think it will look the best for you. All right, so we've got, and that will be negative pi over 3. And we know somewhere over here we're going to have our 2 pi over 3. So let's just make a 2 pi over 3. And then between here and here, try to ignore this line, you're going to put in a middle hash mark. And what will that value be? I don't know exactly. I mean, I could find it out. Because it's between these two, we would have to kind of figure out denominator-wise, but quite frankly, it doesn't really matter as long as you're halfway between there and there. And then we'll put a mark here. And then between these two, let me process this for just a second. I don't know if I'm over a little too far this way to do my halving. So if this was pi over 3, let me redraw this graph because I'm a little on the spacing. It's a little off looking because I put my 2 pi over 3 a little too far over. If this is pi over 3, then it should be more like in here. So let me redraw the graph. And this is where it takes a little thought. I'm going to put my pi over 3 just a little bit farther over. And again, we're just going to mark it at 3/4 and negative 3/4 because that is our amplitude. So if that's pi over 3, then this would be another pi over 3. And then we're at 2 pi over 3. I just want to make it look a little more of what it should be. All right, so this is our 2 pi over 3. But it's now a little bit more evenly spaced. Pi over 3, a pi over 3, a 2 pi over 3. All right, so now we've got that mark, but that's not the mark I need. I need halfway between these two. So if I don't look at those two lines, about halfway is going to land about, because these would both be a pi over 3, so it's going to be in the middle between here. And then halfway between over here is about right there. And halfway between there we go. It's a matter of making sure that you keep it a little more synchronous. Now we could find all the values on that, but it really doesn't matter. We need the pi over 3 and the 2 pi over 3. We need halfway in between and then halfway in between those. All right, so for our, this is a cosine graph. So we know we're going to start over here. So it's going to be up here, and then it's going to touch here. It's going to come down to here. It's going to go back up at this point, and then back up to here. Alrighty. So we're going to curve down, catch that one, curve up, and back up. So there you go. So like I said, make sure you're getting your spacing even, especially if you're not all on one side of the graph, because when I got the spacing off and I was trying to do the halves, I wasn't going to land in the right spot here. So just be careful about that. And it's okay to start your graph a little bit over and getting it exactly where you need it to be.